Hello, everyone. Thank you for showing up on a Saturday. I know you guys are probably just coinciding with the Qatar race weekend. So um, I'm Shubham, and we have Ian with us today, and we're going to speak about the five factors that affect performance of a race car. And just to begin with, I just want to introduce you to our brand, United Motorsports Academy, which is Asia's first technical motorsport academy, of which Ian Wright is an advisor of. Ian himself is going to get a formal introduction by Renita, but I'll keep it short and sweet by saying that he's a former Mercedes and McLaren F1 team vehicle dynamicist. He's worked in the area of vehicle dynamics um, and a lot of the simulator development over the 30 years that he's worked in F1, and is a big advocate of how do you add performance on a race car. And Ian's gonna, utilize his time explaining to you guys which are the factors that make this performance available and allows you to take a big leap of jump in performance. And we're going to take a lot of examples from the F1 season that's going on right now. So again, a lot of you guys who follow the season love telemetry data analysis. This session is definitely for you all. You guys are going to have a good time. But I just want to spend the first 5 minutes just touching upon what we are doing. Um, so United Motorsports Academy, our objective is to basically create an entire ecosystem of motorsports in Asia, and by particularly targeting India first, wherein we give you all access to world class knowledge, so industry certified learning through people who've worked in F1 for 20 to 30 plus years. The Ian Wrights, the William Toits, the Craig Scarboroughs, basically developing a course and making motorsport education accessible to everybody without having to spend 50,000 pounds on a master's degree in the UK, say, for example. But that's not it. That's just a knowledge base. We want to provide hands-on experiences as well. So we're going to have summer internships and we're going to have workshops in order to ensure that everybody gets the ability to work on the car, to learn setup on the car, to test aero parts on the car, to design parts and manufacture them and test them. So that's the second half of what UMA wants to do. And the third pillar of what UMA looks for is affordable global exposure, in which you have the knowledge and the skill sets in a way, but what are these if you do not have the opportunity to apply them? So the third half is where UMA starts offering work placements or internships at motorsport companies or motorsport projects, so that you have the ability to apply your knowledge and your skill sets that you've learned in experiences that basically give you a taste of motorsports. And I think what's our biggest USP, I think, is that people coming from Asia do not have a particular career path, because we don't really have a career path in motorsports. So I think what we are going to look at is we're going to look at every individual. And I say every individual very seriously. And we're going to devise a personalized success path so that you get the best opportunity to have the ability to work in motorsports or do that master's degree that gives you the opportunity to work in motorsports, right? So, when we started telling this to people, people did not believe us. So we said, all right, let us show you how it's done. So we have created our first pilot program, as we so call it. We call it LIME, which is the Launchpad for Indian Motorsport Engineers, which is happening in Mumbai from the 20th to 23rd of this month, October, and in Chennai from the 27th to 30th. Now, what this program does is it basically completes all the three pillars that we just spoke about. It provides access to world-class education because we have Rex Keen, who spent 20 plus years in the field of race engineering and is an associate professor at University of Bedfordshire. We are bringing him down to teach you all what it means to be a race engineer and what a race engineer should have in his mind, so that he is able to execute on race weekends the way we see somebody like GP or Bono execute. Um, Out of those students who attend the workshop, 24 students will be selected to have a fully funded opportunity to work in the Indian F4 Championship, So that kind of covers the hands-on bit that we were speaking about. So you have world-class learning, you have hands-on experience, and then four of the students, provided they're good enough, are going to be absorbed by MP Sports, because the training is going to be done by MP Motorsports. That's the team that Jihan Daruwala runs for right now. And you guys can get the opportunity of working abroad. And if you guys, and then the other four students are going to be absorbed by the Indian F4 championships themselves as fully paid professionals to be able to work from the next year's championship. And then the rest of us, we are going to probably absorb them within our academy, because we have a lot of exciting projects coming up from our company as well. So that's the idea, to showcase people that it's possible to have access to all the three pillars that our company stands for. And this, in short, is what United Motorsports Academy is about. And if you are interested in taking your first step towards motorsports, then do check out our website. It's unitedmotorsportsacademy.com, pretty much the entire name of the academy. And check out the live workshop. It's happening in 2 weeks of time. So the registrations are going to close soon. And if you guys are interested in that, give that a shout for sure. So I'll leave the stage to Ian. I'll just stop sharing my slide, or maybe I'll leave the stage to Renita so that she can introduce Ian more formally before we kick off with Ian. Yeah.
Yes, thanks, Shubham. I believe you've already given the overview of the session, right? So I'll just go ahead with introducing Ian. So Ian has worked for 30 plus years at the top level of motorsports, complemented by 5 years in the aerospace industry. In 1990, Ian became a part of the McLaren F1, where he played a pivotal role in vehicle performance simulation, toolset development for analysis, and competitor comparison. His contributions were instrumental in securing championship for McLaren in 1990 and 1991. Ian's remarkable career can be further delineated into 15 years with the McLaren F1 team, followed by 15 years with the Mercedes F1 team. Notably, his tenure with Mercedes saw a remarkable string of championship wins spanning from 2014 to 2020, cementing his legacy in the world of Formula One. A few general instructions for our audience on Zoom. Please keep your microphone muted throughout the session unless you're instructed otherwise. During the Q&A session, we would encourage you to turn on your audio and video to enhance the interactivity of the session. So without further ado, let's begin with the session. Over to you, Ian.
Right, okay. So obviously vehicle performance is a very big area, and I can talk for weeks and weeks about it. So what I've tried to do here is just pick one example from this season, which I'm sure some of you will have been aware of. Hopefully all of you will be aware of some of what's happened to McLaren. They started out badly and then they improved their performance. So this is just a look at the data level, what actually happened, and perhaps why they were able to do what they did. I've been doing this kind of analysis for 25 plus years. It's very, very useful in a team because you need to understand what your competitors are doing. So if we move on to the next slide, basically what we do is we create a qualifying delta time analysis. DT always in my language stands for delta time. In this case, we look at qualifying laps to try and identify where the car and driver performance varies. We use qualifying because the car is on the limit, the driver is on the limit, the fuel load is on the limit, everything is on the limit. So you get you get the best data that you can to do this kind of analysis. So what are the key areas that we really want to try and identify? And we can do this using this kind of analysis, but this is more general. This is actually probably, for me, is the top level thing that people need to understand in terms of making a fast racing car. You need to look at your aero. You need to look at your engine. You need to look at your tires. You need to look at the driver, and you need to look at the mass of the vehicle. As a very quick example of the mass problem, in 2022, Sauber started the season right on the weight limit, and other teams didn't. And Sauber had a big performance advantage, maybe 0.6 seconds a lap over quite a few teams. And then gradually, the other teams identified that they should have the car on the weight limit, and they brought the weight down, and they overtook Sauber and Sauber drifted towards the back of the grid. So mass is very important, but that's just a very, very simple example. It's not often that teams get it wrong, but when they do, it's very expensive to do that. Now, we can talk about those from a simulation perspective, from a mathematical modeling perspective, and that's a long job because you have to go through in great detail. You have to look at the physics, you look at the vehicle and so on. This way that we're going to look at it is purely based on some data that is available in the public domain, and you get to see, you get access to it if you want to. 2 teams selected so far. I've used Red Bull as the reference because they have had no need to develop their car because they are so quick this year, and Verstappen is so quick that there's no point in them developing their car. Whereas McLaren started badly and thought they would do much better, so they've had to develop their car quickly during the year, and they have done so. The last slide, I will have just give you an overview of the approach. It is quite simple, but it's worthwhile having a bit more background, I think. So this is very typical of the graphs that I used to create many years ago. We didn't have access to this kind of data, so we had to create it. And we created it from video data, and it was a very lengthy process. You're very lucky you get this data for free. It's available on the web, so you can do the kind of analysis I used to do years ago and get real meaning from it. So if I just start to explain the graph. So what I've done is I've picked a few races where data is typical. It shows you something useful. What you should do is look at all the races, and that's what I have done in the background, but I've just picked out a few because we don't have hours to go through this. So the graph here is basically separated into 3 sections. So we have speed on the vertical axis here. We have delta time, this is your DT channel, in seconds. And at the bottom, we have throttle in percentage. And marching across from left to right, we have time. So this is one whole lap. In fact, I think this is distance. I think they have converted this to distance because it's easier to present it in distance. If you leave it as time, your corners will not align. So this is distance against the distance channel. So what you then see is here we have the blue trace, which is Perez from his lap 18, which was a 1:26.841. And then the orange is Norris for his lap 7, and he was 1:28.394. And you can see here that down the straight, we have Perez is much faster than Norris. And we also see generally in the corners, they're not that dissimilar. If this was Max Verstappen, as we'll see a bit later, Max is just quicker. He just is. That's the way he is. Now, the important channel for me, I can see what's going on from the from the car speed trace, but delta time tells me more. So if I look at the delta time trace, the 0 line here represents Perez, so he's being measured against himself, so there's no difference, so it's 0. Whereas the orange line is not Norris getting slower through the lap. So if we look at it, why is he getting slower? So you can see it here, it aligns. He loses very little time down the straight here, which is fairly normal. You don't tend to lose that much down the straight. All the losses start through the corner. So you'd see it into the braking, through the corner and out the corner. Now, in this case, you can see as soon as he goes down the straight here, you can't really see it clearly in the car speed, but you can in the delta time. So Perez is getting out the corner quicker, and so he's going faster, basically. And so through all this section here, he's maybe gained 0.4 seconds. Some of it is down the straight. You can see when the gradient is in here, it's going up, and it's because he's gaining under the braking phase. Now, if we look down this section here, I mean, the speeds are very similar, and so of course the delta time difference remains practically 0. It's a very slight gradient, but then it starts to increase, and that's when the speeds start to deviate, and that's the low drag of the Red Bull coming in. And the longer time they can have low drag operating, the greater they gain. So at the end of the lap, you have the 1.6 seconds or whatever it is, the lap difference. I mean, it's the Red Bull is just basically a much better car. It gains a lot through this low speed section. it's just so much better than the McLaren. So at that point, I'm sure McLaren were very worried and needed to do something about it. Norris also makes a mistake in the last turn around here, which costs him about 0.3 seconds. And you can see when it's a steep gradient, then that means there's a mistake made by the driver generally. Okay, I hope that's familiar. This is where we move on to round 8, where we started to see that McLaren were improving. They claimed that they didn't make their car they didn't add any changes to their car, but they did make their car quicker. I think this is likely due to the fact that they were able to run their car closer to the ground, which is really, really important with a ground effect racing car. So what you see here is, if we go straight to the Delta time trace, so the same again, okay, it's Verstappen that's a 0 line here in blue, but I put both Norris and Piastri on because the car's basically the same, and they do drive with a familiar driving style. They are very similar. What you see is the lines are much closer now. So, I mean, if we get to halfway through the lap, Verstappen is only half a second a lap ahead. And here, I think that's Piastri makes a big mistake and loses 0.4 seconds. And you can see that through the speed trace here. The speed from Piastri is much lower than Norris or Verstappen. So the car has definitely improved here. Another area where you will see that the cars, when they get closer and closer, you'll see that the throttle traces will overlay better. And in fact, in this case, Norris is braking a bit later than Verstappen, and Piastri's braking a little bit earlier, but it's all pretty similar. So the cars are definitely getting closer. So if we move on to Austria, which is where the McLaren had a big upgrade, the lap time difference reduced again. So if we look at the Delta time trace, we've got Max Verstappen on 0 again, and you can see the line for Norris is up and down over the 0 line for Verstappen. So he's driving that car very similar in speed, except for this last bit through here. Max is able to extract a bit more performance there. So by the end of the lap, he's around 0.2 seconds a lap quicker, 0.25 seconds a lap quicker. Yes, it is a short lap, so we would expect to see less of a difference, but the cars are definitely getting closer now. When we see inversions in the line, like we see here, that generally means that there's a slightly different racing line, and you can see that the speed trace is slightly different as well. So what you would do normally is average out across through there, and you'd say, yes, he's getting a very small amount of time, but not a lot. Down the straights, cars are very similar now. The low drag function is not working as well, this circuit, for whatever reason. Now, if we move on to Great Britain, again, Verstappen is very slightly quicker across the whole lap. On the DT trace, we can see the 0 line is pretty consistent with Verstappen at 0 and Norris and Piastri having the same basic shape. So it's this shape that tells you a lot about the car. That tells me they are driving the same basic car, and they're both driving it pretty consistently. Norris just happens to be a little bit quicker in this instance. And as we get to the end of the lap, Verstappen makes a mistake exiting the last 2 corners and loses 0.1 seconds. But basically, it's around 0.2 seconds at Silverstone, which is a very big lap. So they have definitely improved their car considerably there. So in summary, what I would say is that Red Bull has remained the quickest car. McLaren have made big steps in performance at the Spanish and Austrian Grand Prix. I think that, when both the drivers have the same kit on, the cars are so similar and they drive them in a similar way that you get a very similar Delta time trace. And Piastri is very close to Norris in terms of speed against time. Now, if I go back one slide, I've only talked about aero gains. So far we have just seen aero gains because they're the big ones, they're the obvious ones. But you would also see in the shape of these lines here, what you would see is changes in mass, changes in engine power. changes in tyre performance. And there are plenty of other plots which I can produce which will show those things, but I don't have them to hand now because it'll take quite some time to go through them. And it's more in the detail. It is more challenging to go through that kind of thing. And it's the kind of thing that we need to go through in some of the courses that UMA is going to provide, so that you have a better understanding of why these things matter. How do you cost them? What gains should you expect? How easy is it to do? What should it look like? What are our competitors doing? And these are all part of the things you need to do when you're going racing, to understand both how you develop the car in the future, but also during a race event. What happens? Why is it happening? Is there anything we can do about this? So the core analysis approach, I've used all the time laps from Q3. You can't always do this because some cars make mistakes or drivers make mistakes and you don't get the data that you need. So even with high quality data like this, sometimes you cannot do all the analysis that you might want to do. I've always compared with the fastest lap from McLaren, so it doesn't matter whether it's Piastri or Norris. In some teams, you can't always do that because one driver is always quicker than the other. And when they make a mistake, comparing with the weaker driver is not a good thing because you confuse yourself. So you don't want to do that. I assume that the Delta Time channel has enough data to show performance differences and driver errors. This has been my experience for 25 years of doing it. It does, and it's a very good way of understanding competitors' car performance, but also your car, what's happening with your car. Yeah, the last point is quite important. So Q3 versus Q2 or Q1 laps have added errors due to track gain, tyre choices, driver commitment, and so on. So I would be very, very wary of comparing across different qualifying sessions. Okay, it's a very quick run through, but I hope that this has given you a bit of a picture that there's a lot of data out there that you can look at. So you can look at this data for every race event, every race driver, and try and learn something about what's happening. So if you're interested, look at the Tempo F1 website, and hopefully Shib will put up a link for this. There's you have all the information you need there to start doing your own analysis. Shub posts some analysis every now and again, I've seen on social media, and there are others that do this as well. As I said, my favorite, or my desire really, is that people use qualifying data. I'm not so keen on using free practice, but others use free practice and can derive useful information from it. Qualifying is where you get the most detailed and most accurate data. So try having a look at some data yourself and try and work out what's happening, and then get in contact and we'll see whether we can help you with it. Okay, yeah. I'll pass everything back.
Can you go to the next slide, Ian, if you don't mind?
Okay, right. Yeah, sorry.
Yeah.
I wasn't aware of this one.
Yeah, I secretly added it at the end.
You
No,
did.
I'm just joking. Well, this is something that we are doing right now as part of before we start the Q&A, guys, is something that we are trying to understand what is the main limitation right now for you guys to get into motorsports, so that we understand the problems from the students themselves, and that aligns us better to understand what you guys need, so that we can have a chat with Ian, with William, with Peter, and all these people that we have an advisory board to kind of jam to understand. All of us have certain ideas, but if those ideas are not in line with what you guys require, then it doesn't make sense. So I would highly encourage all of you guys to just scan this QR code and fill up this quick form. We are going to have a quick, at the end of this session, we're going to show the results to everybody, so that you know that what you are thinking and possibly what the majority of the crowd is thinking about the questions that are asked in this form. So I'd encourage everybody to quickly do this. And while you guys do this, and we take questions for you guys, I have a couple of questions for Ian. And I also don't, and I think a lot of you guys would like to know the answers to these questions. So Ian, first thing is, I'm quite curious about, you've spent so many years in F1. I'm quite curious to know, when a team brings an upgrade, right? How much does this upgrade really quantify? Like, for example, a team bringing a big upgrade in terms of time, how much does that quantify usually?
Okay, it's a very big question, as I'm sure you're aware. So if I just go back in time, when I first started at McLaren F1 in 1990, we had basically unlimited testing. So we would go to the test track with an upgrade and we would test it on one car, we would test it on another car, we'd do back-to-backs, we do ABA, ABAB tests, and we keep on going until we thought we understood it. Then the FIA reduced the amount of testing, and nowadays, I think you're aware, we're able to go testing just before the season starts, and that is pretty much it. So testing is very difficult. If you go to a racetrack and do it during a race event, your free practice session 1, you need to get the car set up, ready for just understanding the track to make sure everything's okay. Free practice 2 is getting ready for the long runs, and then free practice 3 is getting ready for qualifying. Qualifying is qualifying, and the race is the race. So you just don't have the time to do the testing. So what we all, or what the teams all do now, is try to do everything that they can on the simulator. So the driver in the loop simulator, so you get as accurate a data you can from the wind tunnel, from the tire models, the tire manufacturer, from the chassis, and so on. And you do your testing on the simulator, and then you would just test a small part of it at the track. So you might do one car has one setup or one upgrade on, and the other car has the old car, and then you might swap it around in FP2. But that you'd be really pushing it to do that. It's very difficult to do nowadays. So you're relying on getting very high quality data at the test track in that one session, and you're totally reliant on having all this high quality data back at the factory to do the analysis.
Yeah, and that is exactly what we saw McLaren do this year. I mean, every time the upgrade has been on Norris, and Piastri's been running the older spec of the car, and I think that way they've been able to get good quality data. And I think one of the key things for McLaren, like to see the kind of jump that they have done, is to see that everything that they've added on the car has actually worked. And I think that kind of shows the kind of confidence they have in the upgrades that they're bringing, but also in the correlation work that they're doing back at their factory. But in my experience, just in F1, is that obviously I haven't been in F1 for as long as you have, but every big upgrade that teams bring, normally it kind of targets around 0.1 to 0.3 seconds. Yep. Is that about right?
That is about right. And now what I would say is that this season, 2022 and 2023, are different from the previous seasons because of the porpoising and the ground effect. So if we go back to McLaren, and this is something that Shub and I have discussed a few times, we think, because we've had a good discussion about it, that the performance upgrades in part for McLaren are that they can run the car lower. You see the car sparking much more, and that is where the performance is on their car. They needed to run it low at the start of the season. They couldn't. They had porpoising problems, and so their performance was a long way off from where it should be. Then the upgrades have worked on top of that. Maybe they help with the porpoising, but certainly they also help with giving more downforce. So now the car's quicker all round, and it is quite close to the Red Bull, not far off the Red Bull. Perez car is struggling to compete with them, but Max obviously can.
Yeah, and I think the biggest advantage, the biggest key takeaway to answer the question, is it really ride heights or not, is there's probably ride height is the one factor that allows you to get a wholesale gain of performance across all the spectrums of the aero map. So for some of you guys who don't know what an aero map is, it basically shows you in what spectrum, how much aero performance can you add, depending on what attitude of the car that you run. And ride height is a big factor, and it's probably the factor that allows you to get a wholesale improvement in performance. As you guys can see, McLaren went from being the worst car of the, from the entire lot and the first 2 races, to now being the second best car consistently across races. And especially, it's probably the only car which can do as well, not as well, but is probably second fastest to Red Bull in high speed turns, which is where ride height makes all the difference, because the faster you go, the lower you compress because you have more downforce. And like your dominance in high speed performance kind of tells a lot about your sensitivity to ride heights in a lot of ways. So definitely, as Ian is saying, we do agree that McLaren has added a lot of their secret is basically that they are able to run the car much lower, which obviously in this ground effect cars make a huge lot of difference. You mentioned, Ian, briefly about Verstappen and Perez, right? And a lot of people are asking, um, why is there such a big difference between them? Is it just the pressure, or is it just the driver? I mean, you've seen Nico and Hamilton battle it out. You've seen Bottas and Hamilton battle it out, and usually there was quite a big difference between Hamilton and Bottas on most of the tracks on the circuit. So, is there some parallels that you can pull upon as to why there is such a big difference between these two drivers?
I think it comes down to more how Adrian Newey makes the car work. So Adrian Newey, if any of you were to buy his book on I think it's how to design a racing car. Yeah. So in there, he hints at what you need to do to make a very fast racing car. And it is very simple. Basically, you want to try and control the balance on the car. That's what it comes down to. He tells you that you need to do that. And what surprises me is that most F1 teams don't do it very well at all, whereas Adrian Newey does it very well. And I think that Max Verstappen is able to drive within those limits much better than Perez can. I suspect that Perez wants a car that's just a bit easier to drive, whereas Max just drives it a little bit closer to the limit. And that means he's able to extract more out of the car. Because basically, it's all about getting the car into the corner. If you can get the car into the corner very well, you will corner well and you will exit the corner well. As soon as you're fighting the brakes, the last of the late great breakers, they're always going to struggle to get a car through the corner and out the other side. And then you just lose time down the straight. You're always going to lose time down the straight. Whereas if you look at Max, his delta time traces will always show that he keeps on gaining down the straight. And that's where his lap time comes from. Whereas Perez does not do that. He doesn't get the car out the corner so well. So I'm convinced that he doesn't get the car into the corner as well.
Okay.
And you can see, if you watch them on the on-car video, you can see that they take slightly different lines. They are just a little bit different. And that's enough.
Yeah. Racing
line makes such a massive difference to the driver's performance. And I don't think many people understand this at all. But how do you tell the driver? You're an engineer. How are you going to tell the driver, you need to do this racing line? Of course you can't. The drivers are brilliant at optimizing the racing line, but there's still more to come from them, I think.
Yeah. While we were talking about this, there was a couple of questions that have come on YouTube, and I know, Ranita, you're going to pick up questions from Zoom, but I'm just looking at the chat on YouTube, and there was this, there's this very peculiar question, which is not very which a lot of people ask, is the role of computer scientists in an F1 team. And I try to always advocate that F1 is a sport for everybody. You just have to be good in your field, and there's a role for everyone. Not a lot of people understand this, and I think Ian would be the best person to answer, because he's been the head of engineering of the software department at Mercedes himself. So Ian, for those people who are not mechanical engineers and have joined this, just tell us the role of, let's say, computer engineers or other fields of engineering, or just computer engineers, for example, in an F1 team. Like, how can they contribute to an F1 team to make the car go faster?
Right. So in an F1 team, you record an enormous amount of data. There are hundreds of sensors on the car. They're logging up to a kilohertz. So you have an enormous amount of data. And really, I can't see how anybody can process this data in their head. It's physically not possible. So there needs to be ways that you can take this great big volume of data and simplify it and make it so that the engineer can see the little bit that they actually need to see to make a good decision. In fact, you want to make it as simple as possible so they make the best decision that you can. And that's down to mathematical modelers and computer data scientists to get the data in the right form so it can be displayed very quickly to the engineer so they can make the very quick decision. I mean, race strategy is a typical example of this, and that's been used for many years, but it's true for all the other things that you do on the car that you're trying to optimize. An F1 car is about optimizing very small differences, lots of them, And so you need the people that can analyze, make the tools so it's easier to analyze this data very, very quickly. And that is where the data scientists, computer engineers, mathematical modelers, physicists, etc., all those people come in who you say, well, they're not engineers, they don't understand the detail of how the car works. Well, they don't need to. They just need to understand their bit of the jigsaw puzzle and put it together with other bits of the jigsaw puzzle. And then the engineer at the track makes the call and the car goes faster or the driver goes faster.
Yeah, so that kind of answers your question that, we just don't need mechanical engineers, but we need engineers from computer science, from electronics, from mechatronics, or everywhere basically to make sure that and one of my problems at Red Bull, I remember, was the amount of data I saw. At some point, I just wanted to shut my screen off and just say, stop showing me colors and stop showing me numbers, because it was just too much for me to consume on a day-to-day basis. So 100%, anybody that can make data visualization more conceivable from an engineering sense, I think definitely holds a spot in F1. Another question that was asked was, what do you think of Aston Martin? This is on YouTube, and we'll take some questions from Zoom very soon. But what do you think of Aston Martin's performance? Like how they went from being really good at the start to now they are kind of decline in performance? And I have my own couple of theories on this. And personally, I feel that they took the big step, which is quite easy to take because in a way their car was not really that great. So people didn't expect them to take that kind of a jump. But they also took a relative jump with respect to Ferrari, Mercedes, McLaren, and all of these people. And that's obviously because they did hire a lot of good people, primarily from Red Bull, and they were all playing a role in designing the car. And they had more resources. Historically, the team's been doing quite well. And they also chose to fundamentally go on a different path at the mid-season of 2022. But I think the reason they have downfall is not because they have not been bringing enough upgrades or they've been, they're not good as a team. And I don't know, I would love to hear Ian's perspective on this. I personally believe that for you to compete with a team like Mercedes, a team like McLaren, a team like Ferrari, you can have another discussion altogether. But for you to compete in general with the British teams, I would say, the kind of culture you need, because the way they go about putting on performance on the car is very methodical, and it almost takes time for you to get into that rhythm, into that system, so that collectively you're continuously adding performance on the car. I know how smooth like the operation that Red Bull were, of how aligned everybody were towards one objective. And I feel the kind of, they have a new factory in place, they have new people coming on board, so new ideas, new people don't know who's in charge doing what. And I think these factors, which are very indirect factors, it's not about the competency of an engineer, the competency of a driver or a team. These indirect factors are things that nobody talks about. And when they say that Mercedes was a well-oiled machine, I think Aston right now are just not a well-oiled machine because they're going through a transition period. And that kind of shows because they're not able to add performance throughout the year. But I don't think this is going to be a trend going forward. So what do you think, Ian?
Yeah, I agree completely. The teams are always thought of as being like, there must be an Adrian Newey. That's how you make championship winning cars. And yes, Adrian Newey can do that, but he's had a lot of people that makes Red Bull work very efficiently and effectively. And Mercedes had a lot of that. They didn't need an Adrian Newey because there were enough good people there who could make very fast cars. And they made it work as a team. Toto Wolff wanted it to work as a team, and that's what it does. Now, Aston is a different story. So they played around with their technical director. So Andy Green was effectively pushed out the way, and they brought some new guys in. And it always takes time for the new team to start playing together and playing together well, because that's difficult. Certainly they started the season understanding that they needed to run the car very near the ground, and they did. That was their key performance gain from the previous year, was that they got their car to run near the ground. So that was great. But then they lost their way on adding updates, and I think that is or more management leadership question than anything else, because you've got to get people working together. If you don't, you will not end up with really a high performing car.
100%. So there's a student, Ian, who's basically, I've done a career counseling with him. His name is Anish Armani. He's a kid from the UK, very bright, intelligent kid, I have to say. He's asked a question that, and a very interesting question, I think. How has the banning of the inerter reduced the capability of combating porpoising, and what have teams done on this?
Right, that's a good question. So the inerter was the solution that many of us would have come up with straight away as soon as we realised that there was going to be a problem. Yes, and absolutely. But the fact that it's banned meant that you just had to solve the problem correctly, and to solve the problem correctly means you look at aero derivatives. You basically do this in the wind tunnel. You have metrics that tell you when you're going to get porpoising, when you're likely to get porpoising, and when you won't. And you just tune your metrics so you understand, yes, this will definitely work, or this will work 95% confidence, whatever you decide is your confidence level for taking something to the track. So there is no need for an inerter. I would say, yes, you could have done it in the past, and yes, it would have worked, but you want to solve the problem as a core problem. You don't really want to use the inerter to do that. You have enough problems with the car that you'd want to use the inerter for. The tyres sit there and resonate at 8 hertz, or you've got your pitch mode, you've got your heave mode, and the whole car's moving around all over the place. And that's what you'd want to use an inerter for, much less to fix an aero problem that can be fixed in the tunnel and give you performance at the same time.
Yeah, I think when the whole porpoising problem came, it was like Red Bull almost found themselves in a convenient position, because they had not optimized their car to run at low ride heights. They had not reached that point yet, where Mercedes and Ferrari and McLaren, everybody had a lot of development time, and Red Bull were basically fighting the championship to the end in 2021. So we didn't expect to be as good as we were in 2022, but it so happened that because everybody had optimized, they had basically gone into the wrong window in running the car. When I say wrong window, I mean they had pushed too far extreme into that window for that aero philosophy that was initially there. And there was a lot of effort put into exactly what Ian pointed out as to how do you develop metrics in the wind tunnel that show you indications of porpoising, of bouncing, of peak aerodynamic loads, because that's what it really comes down to. I mean, the phenomena is a aeromechanical vibration, aero-induced vibration in a way. So how do you start developing metrics that show you that peakiness in aero forces at certain ride heights? And there was a huge force. There were people hired, some of them from Mercedes, to basically work on this problem. As Ian said, I think the problem is more fundamentally challenged by not using, let's say, cosmetics in the form of inerters, but actually solving the problem to the core. Meet has this question. Meet Mehta says, sir, does the shape of the side pod play an important role in car's performance? I mean, I think this is a question more for me than for Ian.
I think so. I know nothing.
Yeah. I mean, there's a whole lot of discussion of what the side pods are used for. I mean, they're used for front wheel wake management, etc. But I think, when you come to the not the fundamentals in terms of what this year's side pods are doing very crucially is, like there's a philosophy of the water slides, and there's a Red Bull philosophy, and then obviously you had the Mercedes philosophy, which was a zero pod design, which they've moved on from. But in all of this, what was really, really important is the consistency of your airflow delivery to the rear of the car, especially to the diffuser. Because what I've seen from data and from teams, from some general trends, is that what Red Bull did really, really well, and what Aston did really well with their water slide design, is the consistency of airflow delivery between the gap of the diffuser and the rear tire, because that is such a crucial area of aerodynamics and performance, especially with reducing ride heights. or with just with changing ride heights, that it adds so much grip. And Ian would obviously vouch for this, that adding rear downforce or adding rear performance is basically your golden egg, because you can always tune the front. So, and adding consistency in the rear end is what is even more important, especially in different types of corners. The flow conditions change within the diffuser, and adding that consistency in which your car feels controllable or consistent as you go to different corners is what's important. If you listen to Hamilton's complaints when they were running the zero pod design, it was all about he couldn't predict the rear end of the car. It was always on that note. So I feel that, of course, on this year's car, the side plots do play an important role, but it's not on the sides that they play an important role, but in terms of what is the airflow delivery to the rear end of the car is how they make a big performance. Okay, so we have Hemdur Rahman, if I am pronouncing your name right. Does the car slipping in corners get faster through them by achieving a more sharper racing line? How is it accounted for in the simulations? I think it's a very, I don't know, I don't understand this question really well. What do you mean by sharper? I think when he means sharper racing lines, he means like a V shape, because people always say that you have to have V plots, in your speed delta plot. But basically, I think what he's asking for is, how do you account in simulations different racing lines, or which racing line is better?
Right. So there are various techniques available to us in the simulation world. So we can predict the optimum racing line. We can take a racing line from GPS data, and we can, in the past, we used to predict a line from integrating the lateral acceleration and the car speed. So we've got various techniques available to us. The predicting the optimum is difficult, but mathematically it is possible. And that's probably the way you'd go about it. If you wanted to know the best possible lap time from a certain aero kit, a certain car, etc., you would do that. If you want to understand what's best for Max Verstappen, you take a Max Verstappen racing line and you use simulations there. Just overlaying, and you can do this. Actually, yes, I think you can do this with the Tempo F1 data. I'm looking at a way with a friend of mine to try and make this easier to do. But basically, you have data there that allows you to overlay the racing line for Max Verstappen and any other driver, and then you can start to see what they're doing that's slightly different. But obviously, it's more complicated than just the racing line, because the driver has throttle, brake, steer that they're putting in, and that gives you a racing line based on the car, the tyres, the downforce, everything that goes on. And it's from that you understand, and it is difficult, but you can start to understand what the drivers are doing and why they're doing it. And there are various theories about what the best racing line is and so on. But as I described earlier, the driver's concern is to get the car into the corner so he can get out the corner as quick as possible, because he carries all that speed down the straight. That is what matters on these cars more than any other car. Whereas if you went racing with a Citroën 2CV, then you'd want to maximize the radius, because you've got no power to accelerate your car. You've got to maintain as much velocity as possible at all times.
Mm-hmm.
Just as a very general point, something that I think is really important for understanding what makes a race car work is what we are trying to do. That's the driver and all the engineers. We're trying to optimize acceleration around the lap at all times. We're trying to maximize it. If you do that, you will have the fastest racing car. How you get to that is a very, very big challenge. And that's why there is a grid of teams and there's quite a spread in that time. But basically, it's all about maximizing acceleration. When you start to think about it in terms of acceleration, you start to see things a little bit differently, because it's not about straight line speed. It's about acceleration, always about acceleration. How can I accelerate into, through, out of, quicker, higher acceleration levels? I hope that answers it a bit. It is a difficult question.
Yeah.
And I'd have to go through lots of simulations with people to start to explain things, and I don't have access to any simulations. Well, not really at the moment. Not good enough to show you that.
Okay. I think the next question is also quite interesting. I think Kalhara asks about what are the most important technical parameters a team should consider when tuning a car to a specific racetrack?
I mean, that's what the more in the easy set of questions. So with a typical lap sim, which we've had available in F1 for 25 years now, you would use that to determine roughly the downforce level. So the wing level is the first thing you want to get right. Nowadays, the gear ratios are fixed, but in the past, you would select your gear ratios. So you'd use the lap sim to select your gear ratios. You would consider the tyres, but obviously the softer the tyre, the better the grip. So for qualifying, you would understand which ones you would run. For the race, you'd look at race strategy to understand which tyres you would use when and for how long to get the best track position and the best time at the end of the race. You have choices that you can make there to decide which way you want to go. But basically, it's the most important thing you're selecting is your downforce level. And then it's down to how do you get the best out of the tyres? And that is which camber gauge you want to use, which offset, what camber, what static toe, and so on. What temperature in the blankets, what bulk temperature do you want, what's the warm-up duty cycle for the lap, and so on. There are all these factors that go into the detail of making the tyres ready for that one lap of qualifying, and also for the race. How do you make the tyres last long enough in the race to make your race strategy work? So there's a lot of detail with the tyres, and that's why tyre engineers are so important in Formula One.
I think we are just about on time, but I think one answer that everybody wants to know is, we see a lot of people doing analysis, including myself actually, sometimes over the internet on certain articles. There are a couple of Instagram channels that do this, and a couple of people are doing this as well. And in our conversations, as you've rightly corrected me a couple of times, that it's not as simple as what the data shows you. So I want everybody to, the question I think is, what are the easy mistakes to make when you see a telemetry plot like you've shown in your slides? What are some things that people should just not be like, this is it, it's such an easy explanation? What should people be wary about?
So I would always come back to the basics here. Always compare apples with apples. So that's why I was very clear earlier about saying use qualifying data, and preferably use Q3, because you know then that Max Verstappen is on the limit. You know that Norris is on the limit. You know that Hamilton's on the limit, and the car is set up on the limit. It's at the minimum weight. It's got the best configuration on the car. That tells you most about what's happening. The driver is pushing it right to the limit. Any other time you look at data during FP1, FP2, FP3, whenever you look at it, or the race is just as challenging, because during the race, what we would be doing is telling the driver, back off in turn 8 because you're damaging your tyres. Look after your tyres. You've got to save some fuel. Back off down the straight, lift and coast. And so your data is never high quality to do this kind of analysis, except for qualifying. So always make sure your data set is consistent. And that does limit you. If you're going to do Q3, how are you comparing so how would Williams or Sauber or somebody who's near the back, or AlphaTauri, compare their car? Because they're very rarely in Q3. So then they need to pick cars that are similar to them, that are of consistent performance. You need some consistency in your data analysis experiment here. And if you do that, then it becomes a bit easier. You can start to see, you'll learn then what you can compare and what you can reasonably not compare. And that is the one thing that I shove-nose this, because I tell people, I'm very clear on this, that you need to be consistent in your analysis. And presenting stuff that's not fully consistent is confusing to you, but it's also confusing to anybody that looks at it. So keep it as simple as possible.
Yeah, I think keeping it, they say the KISS acronym, keep it simple, silly, is probably what we need to do in amidst all this data that's available out there. And also watch out for, drivers having different racing lines, because that kind of just a big spike in delta at a certain corner does not mean a driver is slower or faster there. What you really need to see is what happens a little bit before and after that spike, because that tells you whether effectively accounting for different lines, whether the driver has gone faster or slower around that corner, right? But not by just looking at the spiky nature of the plot.
What I would add there is you can. So, for example, if you have a lap where you've got a couple of spikes in it, and they're not big, severe spikes, but you can ignore those, and then you can start to sum up differences based on turn 2 and turn 6 and the straight afterwards. So you can make your own subsectors, basically. And if you do that, then you will also learn more about the car, because you'll see cars that have got similar, the car is configured correctly, the driver's driving it well, and there are bits of a lap you may be able to get very good data from. And in fact, you could do that in the race as well, as long as you know that in turn 8, they're backing off, but in turn 6 and turn 7, they're absolutely on it, and that's representative performance. So you can start to build your own sub-metrics, which have really useful information in. But I wouldn't do that until you've done the basics first. You've really got the basics understood, because it starts to get more challenging. The more into the detail you go, the more difficult it is.
Okay, so for everyone who stayed until this, until the end of this session, I'd like to give out a special discount code for Lime. It's called UMA10. So literally UMA10, United Motorsports Academy, standing for UMA10. And you can use this to get a 10% discount voucher for the Lime workshop. And before all of you guys leave, I think the most important question that Krishna asked, I think, before we close this entire conversation is, which are some of the books that you would recommend for students who are interested in vehicle dynamics, in simulator development, or just in establishing a good foundation? Which are some of the books that you would recommend in this field?
Now, I have to say, that is the most difficult question you've asked me, and I'll explain why. So when I started in 1990, there was a book by Professor Ellis, and it was very mathematical, and it was not really applied. So I have had to learn this myself, basically. So I'm self-taught. I do have a physics degree, so I understand the physics, and this is all physics. So it's not as difficult as I'm making it sound out, but I have had to work it out for myself. There must be good books out there. I will have to do some research to try and find some books that I would recommend for you, because I just don't know, because I've never needed them. It can all be worked out, but you are better off using these books if they're good. So I'll make a note of this and get a list of books, and we'll publish that.
We'll probably do a post, Ian, where basically with this response of the best books to read on vehicle dynamics. So stay tuned on our, maybe most likely on our LinkedIn and our socials. We'll make a post with Ian's answer once he gets back with a list of books that he recommends. So yeah, guys, I think that was all of it. Ranita, if there are any closing remarks, go for it, and I think we can call it a day.
All right. Thanks, Shubham. So I would like to thank Ian for sharing his valuable insights during this knowledge-packed session. I would also like to thank our knowledge partner, United Motorsport Academy, and our audience on Zoom and YouTube for being with us this evening.